Okay, so this little video is going to go over basic mole conversion. So we're going to look at moles, grams, and particles and figure out how to convert in between them. So first, we have to know that moles are kind of the center of all of this. When in doubt, try to convert to moles. That's never a bad idea. Okay? So we can convert moles to two different things. We can convert moles to mass in grams, and we can convert moles to particles. Now, particles, that could mean atoms, it could mean molecules, it could mean ions, formula units, whatever. Okay? Just depends on the substance that we're talking about. Now, if we want to convert from grams to moles, for that we would need a periodic table. So our periodic table will give us the grams per mole for every element. So for example, carbon has a mass of 12.01 grams per mole. So to convert in between these two, we use the molar mass in units of grams per mole, and we get that from the periodic table. Now, if we want to go between moles and particles, we're going to use Avogadro's number. You don't have to know that name, but it's kind of handy. Avogadro's number, and that number is 6.02 times 10 to the 23rd, and that's how many particles there are in a mole. And remember, this is really just a counting word for really large numbers, right? Like a dozen eggs is 12 eggs. A mole of eggs would be 6.02 times 10 to the 23rd eggs, okay? So let's look at how we would use these to do one-step conversions. So let's say that we wanted to convert 8 grams of carbon to moles. Now, we're going to use dimensional analysis for these conversions. So I would start by writing what I'm given, which is 8 grams of carbon. And now I'm going to write where I'm going. The problem is asking me for moles. All right, so I'm going to take grams of carbon and move it down. Now, I always have to do that, right? Always has to come down. I'm starting from grams. Based on this math, the only thing I can convert to is moles. So the unit I'm going to select for the top will be moles of carbon. Okay? Now, I have to figure out what numbers to put in there. To get between grams and moles, I'm going to use the molar mass from the periodic table, and the units of that are grams per mole. So let's look up carbon on the periodic table. We kind of already did that. It's 12.01 because I'm going to round to 2 decimal places. So carbon has a mass of 12.01 grams per mole. What that means is that there are 12.01 grams in 1 mole. So when I put my numbers in, I'm going to make sure to keep the correct number with its corresponding unit. There are 12.01 grams in 1 mole. Okay? Now, grams cancel out, so I'm left with moles, which is what I wanted. Now, to enter this on my calculator, I would multiply through everything on the top and divide by the bottom. So I would put 8.0 times 1 divided by 12.01, and I would get 0.666. This has 2 sig figs. I'm going to go ahead and round that to 0.67 moles. Okay? Now let's look at a mole-particle conversion. So let's say that I wanted to convert 5.1 moles of CO2 to molecules. Right, so again, I'm going to identify what I'm given and figure out where I'm going before I start. I have 5.1 moles of CO2, and I want to find out how many molecules of CO2. I'm just going to abbreviate molecules as cules because it takes a long time to write molecules. Well, not a long time, but longer than I want to spend. Okay, so I'm starting with moles, and molecules are a type of particle, which means I need to go in this direction. So to do that conversion, I'm going to use Avogadro's number, which is 6.02 times 10 to the 23rd. So let's write our conversion down here. There are 6.02 times 10 to the 23rd particles per mole. Okay, so now I'm going to take my upstairs unit and move it down. Now in this case, the particle is a molecule, right, since we're talking about carbon dioxide. So that's how many particles there are in 1 mole. So for every 1 mole of CO2, there are 6.02 times 10 to the 23rd molecules. So on my calculator, I would put in 5.1 times 6.02 E23. Now you can do times 10 to the, but you just have to be careful when you divide by a number with scientific notation using that, you really need parentheses. And I would get 3.07, I'll round that to 3.1, times 10 to the 24th molecules. Anytime you're solving for molecules or atoms, you should expect to get a really large number, and that's what we have here. All right, I'm going to do a separate video showing you how to do two-step calculations, so stay tuned for that.